In this example, we're going to look at reflection where our mirror lines are at an angle. Consider this grid. Here's a diagonal line. We need to know how to reflect a shape in a line that slopes this way. We also need to know how to reflect a shape in a line that slopes this way. Consider this. This line goes across the diagonals of the squares of the grid. We need to know how to reflect in a line that does this. The angled lines we deal with must go across these diagonals in this way. Either that way or that way. Note once again how this goes across the diagonals of all the squares. This line is not one that we would be expected to reflect in at this level. It doesn't go across the diagonals of the squares. So since it doesn't go across the diagonals, we would not be expected to reflect in it. We use the fact that diagonals of a square meet at right angles. We are only dealing with lines that slope this way, so they go across the diagonals in this direction, or this way, so they go across the diagonals in this direction. These would then meet at right angles. Consider the grid here with this diagonal line. We want to reflect this point in the line. We go up to the line like this across diagonals. If we go across diagonals, we meet the mirror at right angles. We go up to the line across 5 diagonals, and we go the same distance past the mirror, giving us this as the reflected point. For a shape, we do the same to each of the reference points that define the shape. Note that this is exactly what happens when you look in a mirror. If this is you, your image appears to be the same distance beyond the mirror as you are in front. Therefore we go 5 diagonals up and 5 across. If you took a piece of string and attached it to your nose, and attached it to the reflection's nose in the mirror, you'd find the piece of string would meet the mirror at a right angle. That's why when the mirror goes diagonal this way, we go up to the mirror diagonal this way. Now consider these shapes. These are the reference points for this shape. This one here reflects to here. One across, one beyond. This one here reflects to here. This one reflects to here. And finally this one to here. Note we've gone 1, 2, 3, 4 diagonals across this way, so we go 4 diagonals beyond to get this point. On a graph, these two lines are the line y equals x and the line y equals minus x. These are two lines that you should just know. We want to reflect the triangle PQR in the line y equals x. Label the reflection P dashed, Q dashed, R dashed. We draw the line y equals x. Look at the reference points for PQR. P will reflect to here. It goes across the diagonal, half a diagonal up to the line, so it goes half a diagonal beyond. Now look at R. It goes across 3 diagonals up to the mirror, so it goes 3 beyond. Then Q goes 3 diagonals up to the mirror, so it goes 3 beyond. P dashed is the reflection of P. Q dashed is the reflection of Q, and R dashed is the reflection of R. Here is the triangle P dashed, Q dashed, R dashed.